Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. My name is Fasihah binti Hussein, and today I will present about the effect of different position of embedded circular cylinder on fluid flow of hybrid nanofluid and heat transfer inside a square cavity. This presentation is conducted as part of my fulfillment for the STQPD6024 course, and I am honored to be supervised by Professor Dr. Isa Hashim throughout this proposal research and project. Okay, here is a brief overview of the topics that I will be covering today. We will begin with an introduction, background research, problem statement, and so on, and finally the reference. So, the first section is the introduction. Okay, so what is the hybrid nanofluid? Hybrid nanofluid is a combine of two or more types of nanoparticle in a base fluid which offer high thermal properties over convection fluid and make it them ideal for the thermal management system. So in this study, I have choose the aluminium water hybrid nanofluid enhanced with copper nanoparticle because of its high conductivity thermal and stability. And the simulation is conducted using the software that is COMSOL Multiphysics, which apply the finite element method to solve the governing equation for the incompressible laminar flow and heat transfer. And the boundary conditions are defined such that the top wall is adiabatic, the side wall of the cavity are cooled, and the bottom cavity is and the bottom wall of the cavity and the embedded circular cylinder are heated. Okay, next is the background research. The inclusion of internal obstacles such as embedded circular cylinders within this cavity introduce complex flow behavior and thermal interactions. The position of the obstacles plays a crucial role in determining the thermal and hydrodynamic characteristics within the cavity. This obstruction can disrupt streamline symmetry, intensify thermal gradients, and induce secondary vortices, all of which significantly affect the flow field and heat transfer efficiency. For your information, the vortices mean that the flow fluid can rotate in the axis, which is straight or curved. Okay, next is the problem statement. Convection in cavities has various industrial and environmental uses, including the heat exchangers, nuclear and chemical reactors, electronic equipment cooling, and certified atmospheric boundary layers. The convection of normal clear fluid with a heated object inside the square cavity has received a lot of attention. However, not much is known about the convection of hybrid nanofluid when a heated circular cylinder is present within the cavity and its location changed along the vertical center line. So because of that, the aim of this study is to investigate the effect of varying the position of an embedded circular cylinder on the flow and heat transfer characteristic of copper nanoparticle enhanced aluminium water hybrid nanofluid within the two-dimensional cavity square. Okay, the next is hypothesis. We have three hypotheses here. One is mathematical model could accurately describe the behavior of the copper nanoparticle enhanced aluminium water hybrid nanofluids flow and heat transfer due to the natural convection in a square cavity, considering the presence and the varying the position of the embedded circular cylinder. The second hypothesis is the position of the embedded circular cylinder within the square cavity significantly influence the flow fields and temperature distribution of the hybrid nanofluid, resulting in varied streamline structure and isothermal patterns. Last hypothesis is dimensionless parameters such as Reynolds numbers and copper nanoparticle volume fraction interact with the position of the embedded circular cylinder to influence the fluid dynamics and the heat transfer characteristic of the hybrid nanofluid inside the square cavity. Next is the research question. So the first research question is, how accurately can a mathematical model predict the flow and heat transfer characteristic of copper nanoparticle enhanced aluminium water hybrid nanofluid inside a square cavity containing an embedded heated circular cylinder? The second question is how do the variation in the position of embedded circular cylinder affect the streamlines and temperature distribution of the hybrid nanofluid inside the square cavity? The last question is how does changing the Reynolds number impact the flow dynamics and heat transfer behavior of the hybrid nanofluid for different position of the embedded circular cylinder within the cavity? Okay, next we go to the literature review. First literature review, according to Ahmed et al. 2022, they carried out a numerical study on natural convection and radiation interaction within a porous cavity using aluminium oxide copper water hybrid nanofluid, and the result is confirmed that the increasing nanoparticle volume fractions enhance thermal transport and reduce entropy generation, thus improving thermal efficiency. The next literature review is from Baulahia et al. 2017. They conducted a numerical investigation into the effect of circular heating and cooling cylinder placed within the square cavity filled with copper water fluid, and their study demonstrated the position and orientation of embedded cylinders significantly affect the heat transfer rate. Okay, next literature review from Mehrian et al. 2019. They explored the influence of an oscillating circular cylinder on mixed convection within a square cavity filled with copper aluminium oxide water hybrid nanofluid. And this highlights the role of geometric positioning and fluid structure in interaction in thermal enhancement. So the last literature review is from Suresh et al. 2012. They do the experiment to investigate the aluminium oxide water hybrid nanofluid in a laminar flow through a uniformly heated tube. Their study showed a maximum enhancement of 13.56% in the Nusselt number at a Reynolds number of 1730 compared to the water. Okay, this is the research objective for my study. So the first objective is to develop a mathematical model for two-dimensional natural convection of flow and heat transfer of aluminium water hybrid nanofluid containing copper nanoparticle within the square cavity with an embedded heated circular cylinder. The next objective is to investigate the effect of varying the position of the embedded circular cylinder within the cavity on the streamlines and isotherm of the hybrid nanofluid. The last objective is to analyze the influence of varying dimensionless parameters such as the Reynolds numbers on the streamlines and isotherms behavior of the hybrid nanofluid inside the cavity with different cylinder position. Okay, for the information, the varying the position of the embedded circular cylinder, I have three different position. That is at the bottom, in the middle, and at the center, and at the top cavity. Okay, next we move to the methodology. Okay, this study investigate the influence of the position of an embedded circular cylinder on the natural convection flow and heat transfer characteristic of an aluminium copper water hybrid nanofluid within a square cavity. Okay, as you can see in the figure, show that the geometry configuration of the problem. Okay, so this one is the cool wall. The side of the cavity is the cool wall, and the bottom is the heated and the embedded circular cylinder with radius r, and the bottom wall is the adiabatic. At the top one is the adiabatic. Okay, next we go to mathematical modeling. So governing equation. To address the first objective of this study, the two-dimensional continuity momentum and energy equation for the laminar flow of a steady incompressible fluid nanofluid are taken as follows. So for the first equation is the continuity equation. The second equation is for the x momentum equation. For the third equation is the y momentum equation. Meanwhile, the fourth equation is the energy equation. Okay, so we move to the boundary condition. Okay, the top adiabatic wall, we use u equal to v equal to 0, delta t equal to delta n equal to 0. So this implies no fluid motion, which is no slip condition, and 0 normal temperature gradient So idea for modeling thermal insulation. Left wall also, no slip condition is applied, and this setup allows us to study how cooling from vertical walls interact with heating from the bottom wall and circular obstacle. So this equation will be made two dimensionless, and then simulation for the velocity, stimulus, and temperature distribution will be done using the software, COMSOL software, via the finite element method, FEM method. Okay, number two, effect of varying position of circular cylinder and problem parameters. Okay, the numerical investigation focus on behavior of copper aluminium water hybrid nanofluid inside a square cavity with an embedded circular cylinder located at three different positions. Simulations are conducted across various Reynolds numbers to evaluate the effect of obstacle positioning on fluid flow and thermal characteristics. In each case, streamlines and isothermal contours are analyzed to assess the flow behavior and heat transfer performance within the cavity. Okay, so I also include the COMSOL 6.1 step-by-step guide. Okay, so we will start a new model. So in this, we have in the COMSOL, we have 1D, 2D, and 3D. So this one, I choose the 2D model for my study. And for the define the